Hello everyone. This is a short presentation on a systems view of renewables waste management. This has been developed based on the article Clean Energy Must Use the Battery of a Circular Economy by Akanksha Tyagi, which appeared in the Hindu dated 17th March 2022. This article highlights that as India transitions towards clean energy technologies, it is imperative that the country also establish efficient renewable energy waste management and circular ecosystem. Some of the policies proposed in the article are statutory requirements for recycling, ban on the renewables waste landfill and burning, R&D investment in recycling, recycling technology transfer, financial incentives for recycling, improved product design, and stringent product quality standards in government tenders. As a system dynamics modeler, I was interested to visualize how these policies at a broad level map to the outcomes of interest. Now, causal loop diagram is an apt tool for this purpose. At the outset, what you see here is that a clean energy demand increases, there will be more number of clean energy projects, and as the number of clean energy projects increases, the clean energy components in use in the economy increases. Over time, these transform into waste, and without any policies, it goes to waste landfills and burning, causing pollution. At the same time, with increased component use, it means raw material extraction also increases. Now, if we consider three of the policies, one is ban on waste landfill and burning, statutory requirements for recycling, financial incentives. All these three contribute to attractiveness for recycling of waste. If we consider additional two policies, recycling technology transfer, R&D investment in recycling, this contributes to waste recycling feasibility. So attractiveness for recycling of waste and waste recycling feasibility together contributes to increased waste recycling capacity. With higher capacity and a continued attractiveness, recycling of component waste happens. This yields two results. One is it reduces the waste landfills and burning because the waste is routed to recycling. This reduces pollution. Second is because the raw materials can be extracted through recycling, the industry dependence on raw material extraction from nature reduces. Additionally, if we consider the improved product design as one additional policy, it reduces pollution by reducing the quantity of polluting materials per component. Another impact of this particular policy is that if you reduce the number of steps required for recycling, say we increase the recycling process efficiency, then it increases the attractiveness for recycling of waste. Lastly, stringent product quality standards in government tenders increases the product life and where reduces the rate at which the component waste is generated. This reduces the waste landfills and burning and thereby pollution. I also feel like when the product life is improved and the component waste generation is reduced, it means the waste recycling capacity is at a more manageable level. And that means it will improve the attractiveness for recycling of component waste. So overall, this particular slide shows how all the different policies which are highlighted here, which is given in the article, how all this contributes towards the outcomes of interest, mainly how it reduces the waste landfills and burning, thereby reducing pollution, and on the other hand, how it can reduce raw material extraction from the nature. Hope you found this presentation useful. Thank you.